for our wonderful Unit 3 reasoning. It's where we started the proofs, and I know you're so excited. Well, this one, the order just flips around, so you would say symmetric. And right here, if you notice, we go ahead and we plug that 30 in. So we have a C, and then it says C equals 30, and we plug it in here. That's called substitution. And over here, AB equals AB. Oh, that's just simply reflexive, right? The same thing. Okay, and then here it says x equals y plus 1, and y plus 1 equals z. Then x equals z. Well, we're taking these two things that are equivalent, we're crossing them out and saying they're equal to each other. That is the transitive property. All right, and then here, all we're doing is moving the x, or the 8 over, subtracting it to both sides. So subtraction property of equality. And then here it says if PQ equals 16, then 2PQ equals 32. Well, we just multiplied both sides by 2. So multiplication property of equality. And then here, whoops, sorry, made it a little small. R is the midpoint of TS. So this would be T and this would be S, and R would be right in the middle. Then TR and RS would be congruent, and that would be definition of a midpoint. Okay, and if AB equals CD and CD equals AB, well, they just flipped order. So again, that's symmetric. And here, if B is between A and C, here's A and C, and B is right between it, then AB plus BC equals the whole thing. Segment addition. Okay, well, moving right along. These lines are parallel, and it wants us to give all the measures. So right here, I know that angle 2 would be 126 because it's corresponding, and 2 is corresponding with angle 6, so that would be 126 also. And it is also corresponding with 11, so this would be 126 as well. Then I'm going to go through and find all the angles it's vertical to. So angle 4 is 126 because they're vertical angles. Angle 8 is 126 because 6 and 8 are vertical angles. And, oh, this was a flubub. This angle 10 is supposed to be 126, which makes 12 126. And then, of course, we see that, hey, that's a linear pair. So 180 minus 126 is going to give us 54. That means all of our other remaining angles are equal to 54. This is so nice. I'm so glad I finally have this iPad and pen all worked out. Okay, so angle 1 is 54 degrees. Angle 7 is 54 degrees. 2 is 126. 126 for 8. 9 is 54. 3 is 54. Wow, my handwriting is really terrible on this, though. I apologize. 126. 126. Angle 5 is 54. Angle 11 is 54. And 6 and 12 are both 126. It's nice that both line A and line B were parallel. Okay, moving down here. Well, what I'm going to point out right off the fact is the relationship, and they're corresponding. Corresponding angles. And we know that corresponding angles are congruent to each other. So I'm going to go ahead and do 2x plus 42 equals 3x plus 2. All right, I'm going to start solving. I'm going to get 42 equals x plus 2. I'm going to subtract 2 and subtract 2 and get 40 equals x. And that's my answer. All right, moving down here. Well, I can see that these angles are alternate exterior angles, which are also congruent. So I'm going to do 8x plus 2 equals 10x minus 34. I'm going to subtract. I'm going to get 2 equals 2x minus 34, and add 34 and add 34, and get 36 equals 2x. Divide by 2, and get x equals 18. Okay, next up. This one's tricky. It's almost like you want to ignore this line and see it as this angle right here and this angle right here. There are alternate interior angles. So in order to do that, I'm just going to go ahead and I'm going to set them equal. So 3x equals 102. And I got 102 by adding 80 plus 22. That's where I got the 102. So I divide by 3 and divide by 3, and then I get x equals 34 degrees. All right, moving down here, angles 1 and angle 7 are right here and here, which are touching lines A and B. All right, that means that the parallel lines would be A is parallel to B, and the justification here, those would be alternate exterior angles. Okay, over here, it tells us about 9 and 11. So here's 9 and here's 11. Well, those are vertical angles, but they can't prove lines parallel. So cannot prove. And then, last but not least, I'll jump to orange here. 8 and 9. Well, here's 8 and here's 9. Those two angles are touching lines L and lines M. So L would be parallel to M, and that would be because they are same side interior angles. They add to 180. All right, moving down to everybody's favorite, proofs. All right, 1 and 3 are supplementary. That's our given. 1 plus 3 equals 180. That's definition of supplementary angles, right? Angle 1 and 3 are supplementary. So 1 plus 3 equals 180. Well, 2 is congruent to 3. All right, well, that's because they're vertical angles. Angle 1 plus angle 2 equals 180. So this angle and this angle, well, that would be because they are same side interior angles. 1 plus 2. Oh, whoops, just kidding. We can't say that. Let me erase here. Oh, my eraser's not working. Here's the eraser. Okay, whoops, now back to here. What I'm going to say here is actually substitution, because I'm going to take this 3 and I'm going to replace it with 2 because I know 2 and 3 are congruent. So substitution. Okay, and now that I know that 1 and 2 together add to 180, right? I can say same side interior angles converse. All right, and moving right along, I have this wonderful proof. Okay, so I want to prove that angle 1 and angle 3 are congruent. I'm going to jump back to blue here. So CD is parallel to BA. That's given. And just because I'm telling you guys this all the time, I want to extend my lines just so maybe you get a better visual. All right, well, 2 is congruent to 3. These two angles, that would be because they're alternate interior angles. And then BD bisects CBA, that's given. So here's BD. It creates two congruent angles, angles 1 and angle 2. And that's because it's definition of an angle bisector. All right, and then we see, 2 is congruent to 3. 2 is also congruent to 1. So if we skip over angle 2, we can say angle 1 and angle 3 are congruent, which would be transitive property. All right, moving right along, complete the proof below. Okay, so 2PQ equals PR. All right, let's write that in our given. 2PQ equals PR. And then it's going to be segment addition. So we're going to say PQ plus QR equals this whole segment. All right, so PQ plus QR equals PR. Okay, well, if you notice, we have this equal to PR and this equal to PR. Then we're going to skip over PR and say 2PQ is equal to PQ plus QR. That is going to be transitive. And then what we do is we go ahead and we subtract a PQ from both sides, which is going to be subtraction, property of equality. And last but not least, we now know that PQ and Q are congruent, so we can actually write Q is the midpoint of PR. Okay, complete the proof below. And I'm going to just fill in my given here. So Km, ray Km, bisects angle JKL. All right, the reason is it's given. So what I'm going to do is I'm going to go ahead and highlight those two as congruent. And it says the measure of angle JKM and the measure of angle MKL, so these two angles, are equal, and that's because of definition of an angle bisector. Okay, next up it says angle, here let me switch to pink, angle JKM plus MKL equals the whole angle JKL. All right, that's angle addition postulate. Okay, so then it says substitution. Well, if we see that JK is equal to MKL, what we're going to do is we're going to say measure of angle JKM plus the measure of angle JKM equals the measure of angle JKL. All right, so JKM and JKM equals JKL. Then you notice we combine like terms or simplify to get it to be 2JKM equals JKL. And last but not least, I want it to be, I'm going to divide by 2 and divide by 2. And that's how I'm going to get this. Which there is a typo here. It should technically be JKM equals 1/2 JKL with the way the proof is written. So this should be JKM. Anyhow, and you would write division, property of equality. And that's it for this unit, guys.